Welcome to the ASEF podcast. My name is Tanja Janko, ASEF Fellow 2019. I studied chemistry at the University of Zurich and chemical technology at the University of Ljubljana. I'm hosting the Science Vertical, where we will navigate diverse landscapes of knowledge from the depths of quantum physics to the intricacies of social dynamics. Together we will uncover the mysteries, discuss the current state of research, and discuss the challenges that shape these fields. In the previous episode of the ASEF podcast, Frank spoke with 3 guests about the venture capital, and today we will be talking about computer vision. And it is my pleasure to introduce 2 experts in the field of computer vision. With us are Žan Gojčič, who is a senior research scientist at Nvidia. His research focuses on 3D deep learning, weakly supervised learning, and domain adaptation. And Aljoša Osep, who is a senior research scientist at Nvidia, working on learning how to understand the dynamic world from raw and unlabeled streams of sensory data. Thank you both for joining us today. And I have to say that I'm very excited to talk about this topic because human vision is something that we do and process unconsciously. And for the longest time, it was really difficult for me to wrap my mind around why is it so difficult to generate realistic images on computers. Let's kick off with a first question, which is what initially draw you to the field that you're currently in and what continues to motivate you to do your research?
Thanks for having us in the first place. Very happy to be here. So personally, I come from more a photogrammetry background. So my undergrad was in photogrammetry, and I only started working on 3D computer vision during my PhD. And what actually got me inspired was basically the early successes in deep learning in computer vision. So this was like the era of after AlexNet, ResNet's coming out, things actually starting to work in like 2015 or something like that. And also the fast progress in the field. So back then, I guess most of the stuff was focused on 2D computer vision, and 3D was in its early stages, where we were basically taking the ideas from 2D and trying to somehow apply them directly to 3D data. And it was immediately obvious that there's like really a ton of challenges already on the representation side. Like, how do we even represent the data? 2D computer vision had this like privilege of having images in a nicely like uniform grid of pixels where everything works out nice. And in 3D, this is not the case. So this was kind of the motivation. And what keeps me motivated currently in my research is that there's still a lot of problems that are unsolved. And, we are kind of perceiving the world around us is like 3D or 4D if you want to add dynamics and time. And this is also how we are kind of perceiving it with the stereo vision. So this is why I think that in the future, we already see that there's like a large shift towards 3D. There's more and more 3D in like the big conferences. Models are more and more 3D aware. And I think this is also where the future will go, like adding probably time and other dimensions.
From my side, I would say that where the point at which I really started thinking about these things was when I was a kid already. So I was really interested in initially, of course, playing computer games, right? But very soon I started wondering how does all this work, right? So computer games are in some sense these wonderful virtual worlds where you have all these virtual characters that in some way you can interact with, right? And I was really fascinated by this, and I started wondering how does all this works, right? So where are these virtual worlds stored, and how? And this is how I started slowly discovering computer programming, right? And back at the time, that was just this almost magical to me that there is a language in which you can also define your virtual worlds, virtual characters, and so forth. And this is also what it inspired me at the beginning to go and study computer science. And during my bachelor and master studies, I was actually focusing on computer graphics exactly for this reason quite a lot. And I actually started kind of transitioning from rendering or computer graphics to computer vision when I was doing my master's, right? I was doing my master's at a computer graphics group at University of Bonn, and they had all these camera rigs and devices that you could use to, capture multiple images of objects. And the problems that I was working on there were mainly related on recovering geometry of these objects, right? So 3D reconstruction. At the beginning, I was looking into this in these well-controlled environments where you could put certain object on a table, it would rotate around, you would capture photos in this environment and use these photos to reconstruct the shape of the object. It was then, I still remember, I think this is one of the talks that I remember the most, and I found it really inspiring. So Sebastian Trön, who did his PhD also at the University of Bonn, visited the University of Bonn and gave talk on his path in autonomous driving, and he also outlined existing open challenges in this field. And I think that this really motivated me to really switch my focus to computer vision. And just for context, Sebastian Trön, he's the one that was behind Stanley, this blue Volkswagen that has won the DARPA challenge. I think it was in 2004, 2005, right? So it was the first car that successfully completed this route in the Mojave Desert. Yeah, so this is how I got into this.
Okay, so Aljosha, you already started mentioning a little bit about your studies and that you studied at the University of Bonn. Then you continued with your PhD at the University of Aachen, and Žan did your PhD in Zurich, so you both have an experience of studying abroad. So what do you think is the difference between studying in Slovenia versus abroad? And is there any advantages of studying abroad versus in Slovenia?
So just first for context, I did my bachelor's in Slovenia, at the University of Maribor, and then my master's, PhD, and postdoc I did abroad, right? So I did my master's in Germany as well as PhD and part of the postdoc, and for the second part of postdoc I did in US at Carnegie Mellon University. And actually, I would first start with what is common at universities in all three countries. And I would say that what is common is that everywhere you will really find top talent, right? Both in terms of professors and students, right? They are world-class professors everywhere. But I think, and students, of course. But I think that one big difference between this difference, especially emphasized in US. But I think that one big difference is that in Germany and especially US, there is more accumulation of talent from the whole world, right? Everyone from the whole world is applying to top US and European universities. So I think that at Slovenian universities, it's a bit harder to reach people outside of Slovenia. I think this is one difference, and there's one more difference that I would expose, but I think that this is more difference between US and Europe, right? So I think that Slovenia and German universities, professors have in general much higher teaching burden. Generally, they have to teach more courses, and I think that because of that, professors in US have more time to devote to research and supervising students. Yeah, so I think this is the second difference. And the third one is, I would say, resources. So I would say that German and US universities have much more resources, right? So for example, in Germany, we had quite a lot of access to expensive equipment, such as robots, right? We had actually humanoid robots at the robotics lab at the University of Bonn, also in our group at RWTH Aachen, where I did my PhD. We actually had robots we could tinker with, and this was very fun. And US here is, I would say, even next level, right? So I remember there was always this group of students walking around CMU campus they were working on actual so-called lunar buggy. So actual vehicle, they were supposed to land at some point on the moon, supposed to operate there, right? And there was actually a group of students working on this, so this was very cool to see. And also the department where I did my master's, right, they had also really expensive equipment for capturing images and videos of objects with very well calibrated cameras, right? And and dense enough coverage that you could actually capture kind of images that allowed you not only to recover geometry of objects, but also the reflectance properties.
Okay, I guess it's my turn. So yeah, I second everything that Aljosha has said. Maybe also to give a bit of context, I also did my bachelor in Slovenia. That was at the University of Ljubljana. And then for master, I moved to Graz, so to the Technical University in Graz. And then the PhD was at ETH in Zurich. And in between, I also visited Stanford for a couple of months. So I also experienced the US universities a bit. So I would really agree with the point that everywhere you go, you have like very good students and very good talent also among professors and, other academical staff. So I think that's not the lacking point. What I think is different on what, like, apart from what Aljosha has already mentioned is the diversity that you get at foreign universities. So there's, like, as he said, like a lot of talent coming from different countries, and they have different perspectives to the problems, different way of working, and you can basically see how other people approach problems and then try to find your best way. Another thing also in terms of diversity was the curriculum for me. So I felt that I had much more freedom, for example, at ETH, but also before at TU Graz, to like select my courses. So they had to be connected to my primary direction, but I had more freedom to actually tap into my interests on the side. Another thing that I felt was that, like, this universities in also like German speaking place and also in the US, they're very good at connecting themselves on a like project basis. So even though they might not have as many resources as like their own entities, they connect to other universities and then they share the burden of the resources, at least somewhat. And I think this would be important for Slovene universities as well, to like open themselves to the European space or to the US space, try to seek collaborations on projects. One also important difference, and at least I think is like a difference, I actually didn't do my master or PhD in Slovenia, so I don't know. But for example, at ETH, the students in their master, they already started doing research. So they were already aware of research. And in the US, this is even more clear. And in like China, I guess even more. So like even during their bachelor, they already start thinking about research problems. They take research projects with their colleagues from grad school or professors, and they aim to publish papers. So the reality of the field is that getting, for example, like a PhD position at top labs in top universities is nowadays really hard without having prior publications in top conferences. And if your university is not encouraging this, is not even like telling you that this exists and like motivates you to do research, it's almost like closing the door to the top labs. It's really hard to get in without that. And I think then the final point is that, for example, the language is really an important barrier. And I feel like Slovene universities insisting in having even the master courses mostly in Slovene. At least this is like how I know things. Maybe it's different already now, but this creates a huge barrier both on the like hiring top professors as well as like attracting top students, because I mean, of course, they will go to areas where they can converse and in English. This is obvious, and I think universities in German-speaking place, they have also seen that. So, for example, ETH had the undergrad, so like the bachelor was still in German, but all master courses were in English, and this was default. And you had a lot of professors that didn't speak German, even after being there for like several years, or like French or Italian or any other national language. So I think being open to this, especially while being like such a small country as Slovenia is, this becomes really like crucial if you wanna like stay in touch and like, you know, keep the level of education and research. So yes, I think this would be the biggest differences. But I also wanted to add at the end that I always felt that my bachelor gave me extremely good foundations for my master. So when I came abroad, like I didn't feel that I had like a lack of knowledge or that I was behind my colleagues. So I think that's really good. Or like I think we should like continue doing things that we do good and try to like encourage maybe more students to actually try, you know, do a semester abroad, try to get some experience, get collaborations, and open the door to the students, because I think this is the only way that, you know, we will maintain the quality of education that we want.
I completely agree with both of you. And so also I think something that is a relevant question to both of you, since you both finished relatively recently. Why did you decide to go to the industry instead of staying in academia?
Yeah, so for me, I before finishing my PhD, I did like an internship. This is like one of the points that I forgot to mention. So it's very common in these foreign universities to do like summer internships in large industrial labs. So in the summer or like even during the semesters, PhD students go for a couple of months, join research groups at big companies and do research, like industrial research. And the reason for that is because even though universities have a lot of resources, these big companies usually have even more resources, and there's a lot of talent accumulated there. So for me personally, the decision to go to industry was I continued in the same group where I did the internship, and I had like really good impressions of the group, and like the people that were in the group were like incredibly strong. They were doing like top-notch research in 3D, like really on the forefront. And this is what motivated me. Like I felt that I had a chance to work with these top researchers that were like more senior than me. So they were kind of like mentoring me in my research path. And I felt that this was maybe less so possible if I would continue my path in the like academia, like pursuing for maybe like a postdoc or later a professorship. So this is one thing. And the other thing was I wanted to work on real world problems. Like I wanted that my research would have an impact on like product, but also like in general on the industry. And in academia, unfortunately, often the research projects are exactly that. They are research projects. They're like some man-made or like problems that we make up. We try to solve them. Of course, we are advancing the field together as a whole, but usually the paper, like the outcome of a research project is a paper, and that's kind of the impact that you do. And I wanted to have more like an impact that is concrete and like, yes, makes it to a product, for example.
On my side, I cannot really answer this question fully because I didn't really fully decide yet that my future path will be fully in industry and not in academia. So actually, after my PhD, I did do postdoc, and I still have academic career in mind as a possible future path. But I think that even if I decide at some point to go back to academia and apply for the faculty tenure track, I think it's also really important to gain exposure and experience from industry, right? As Žan said, and I completely agree that academics sometimes live a bit too much in their own world, right, and make up problems that might not even really exist, right? And I think this is why it's important to get grounded and to see what problems industry is facing and how things work there. But at the same time, I would say that even though I was up to a year ago quite convinced that I will eventually go back to academia, this is actually no longer the case. I might, but I'm not sure because I'm really enjoying my time at Nvidia. And as Žan said, and this is another thing that I fully agree with, it's really amazing to see how the work you're doing doesn't just lead to a paper that you then forget about it and move on to the next problem, but to actually see that you can make broader impact than that, right? You can actually see how some problem that you propose a potential solution to, how this can have impact across a wider organization, across other teams that are working on related problems, and potentially even outside of that, right? How this could possibly even impact end customers and improve their lives. So that's really, I would say, a wonderful thing. And another aspect of this is, of course, that I also, just as Žan, ended up in really fantastic research group. We have a lot of great people, great engineers, great scientists, and it's just such a pleasure to collaborate with them, right? I feel very comfortable right now in the group where I'm working at the moment. And also at some level, I feel that we have a bit of both, right? There is definitely still quite a lot of the academic vibes, right? Sometimes really just try to work and find solutions for problems where there are no solutions yet, right? And we kind of move fast and break things and build the first prototype, right? Then if this works out, then we can kind of start transitioning towards consolidation of that, right? Start towards building a product out of this prototype, right? So we have both academic vibes, fast-paced research, and more product-oriented and engineering-oriented people and mentality. And I think it's great to be exposed to both.
And now I think it's time that we dive into the topic of today's podcast. So let's, before going into the current state of research, just talk a little bit in general about what is computer vision and what are some common applications of computer vision in today's world.
Okay, so first just talk a bit about the difference between the two. So I think that the difference between graphics and vision is nowadays kind of getting more and more blurred. And I actually think that's great. But I think that classic sense, I think that people usually think about graphics as kind of a forward problem. You have in one way or another a representation of the world and objects, and you want to render this from certain viewpoints, right? And get as realistic as possible rendering of this internal representation. I think that vision is in some sense kind of inverse of that, right? You are actually getting images or videos or even the other kinds of sensory data as an input, and you're actually trying to make sense of this data, right? Or estimate state of the world from this, in a way, already rendered images. When it comes to applications, in terms of computer graphics, I think there are tons of applications, of course, in entertainment industry, right? Computer games, movies, and so forth. When it comes to computer vision, I think that one big application of computer vision is, of course, robotics, right? These days, for example, one field that we are really trying to move forward is, as I mentioned already earlier, autonomous driving. Right. If you want to have autonomous driving vehicles, then you absolutely need computer vision for that, right? Because autonomous vehicles will be equipped with sensory data. Very often that will be cameras. More likely than not, this will also include sensors such as sliders. And at each point of time, if you want to navigate around the world, you have to make sense of what you are seeing with your sensor, just as humans do. Then another thing that where I see these days quite a lot of applications of computer vision is also, for example, real estate. Nowadays, if you are looking for houses and apartments, you will have these very, very beautiful 3D models of these houses, right? You can do a virtual tour of houses, these properties. You can move around with the mouse and get good impression of how a certain listing might look like even before you decide or not physically visit the place. Another example where I see a lot of application of computer vision is also digital archiving of all sorts, right? One is, of course, archiving of documents and, doing OCR of these documents and document analysis, or even beyond that, right? 3D reconstruction of assets, which might be important for industry, museums, and so forth. Then I would also mention medical imaging, right? Classification of tissues and so forth.
Yeah, I don't know if I should add something because I think Aljosa covered most of the points. I agree that classically these two were seen as kind of the inverse of each other. Graphics being the inverse vision or the other way around, vision being the inverse graphics. Apart from for the applications of vision, I think that there are also a lot of applications where we don't even realize that vision is behind it. Like everybody on their phone uses facial recognition to unlock your phone. This is basically a computer vision algorithm that runs underneath. There's a lot of, I guess, people are getting excited by all the generative AI that is coming out. You can just specify a short text description of a scene and get photorealistic images or videos generated for you in a matter of seconds. So I think that there's a lot of applications that are already there, and maybe we don't even think about them as computer vision applications, but they're all around us basically. So I think also in this, automatic shopping centers, where you can just take the objects, put them in your basket, and basically just leave the store, or there will be a computer vision algorithm that will recognize what you have taken, and basically accumulate the price. So I think it's already there are a lot of real world applications already out there, and I think more of them are coming in the future. So it's really exciting, and I think we should embrace this.
Now, perhaps, Žan, you can continue a little bit more on 3D computer vision, since Aljosa answered quite extensively the previous question. Answer what needs to be synthesized, basically, to create a realistic scene.
Yeah, that's a good question. So maybe just first on the word synthesize, because I'm not sure if this is everyone is familiar with the term. I guess there's two ways of getting the 3D scenes if we are talking about them. One is like to reconstruct them from the environments, as Alyosha has mentioned. You have like image data, maybe some LiDAR, some other observations of the environment, and you try to reconstruct what was in that environment. The other way, like synthesizing, means more like generating them almost from scratch without, or like some text description, some very high level description of the scene, and you want to generate the assets. And for example, in the more traditional sense, this meant coming up with a 3D geometry. So basically the geometry of the object, then attach them some material properties or some textures, have some lighting so that we could like light the scenes and render the images. And then, of course, there also needs to be some physics if we want to interact with the scene. So we need some material properties, we need some physics engines behind it so that if I pick this like digital asset, that it actually reacts as it would in the real world. So I guess the scenes were decomposed into these properties, or so this was also kind of like as like an inverse rendering. For example, if we think about it, like we had all of these different properties that the scene was described with. Nowadays, I guess there's also like an alternative way of doing this. It's like encoding everything in a so-called like latent space. It's just some like latent representation or some abstract representation of the environment that humans don't know how to basically decode, but the networks learn how to decode this thing. So you could imagine this as just like being encoded into some set of numbers that describe the scene. This is not structured in 3D. This could be what we call like tokens or whatever other thing that doesn't actually, is not like positioned in 3D, but through some operations actually can be decoded in a 3D signal. So like what needs to be synthesized is like an open question. We don't know what actually the best representation is. It's like the first one, of course, when you're like decomposing everything, is very interpretable also for humans, or we see the geometry, we see the material properties. But the problem is that often like small mistakes in one of these things, they will lead to then like worse results when perceiving this scene. So, like if your geometry is slightly off, it has high frequency noise, then when you relight it, you will see artifact. And this might be a very tricky problem to solve. Whereas if you model everything together and then just like, learn from a lot of data and let your networks reason about it, then some of these problems might be easier. But then, others might become more hard with like how to ground these solutions, how to regularize the space so that we're actually reconstructing some meaningful scenes.
If there are any challenges that you guys would like to mention.
There are a lot of challenges and problems. And I think the biggest one where everything stems from is the lack of 3D data. So we have seen like really great progress in 2D generative networks where, like this text to image kind of models are really basically hard to distinguish from real world images nowadays. And 3D is lacking. And one big problem that is like the lack of 3D data. So what we see is that actually the researchers and companies, what they're relying on is actually like training these 3D generative networks through 2D supervision. So basically supervising them at the end with the images, because this is where we have the abundance of data. So I think this is one big problem that I'm not sure how we will address, but I think that like videos might act as like a very good representation, which is somewhat in between. Or so it's still like a 2D in terms of like we see if we consider single frames, but then we have the motion of the camera, we have the motion of the assets in the scene. So there's a lot of 3D cues in the videos. Another challenge is like, how do we make this representation useful for the downstream tasks? So we said like, how will it make life of artists easier? How will we speed up the workflows? If you consider now state of the art 3D generative models, where basically let's just consider object centric. So like we only output like single objects, not full scene. Even these are very different to what artists are used to nowadays. So artists are used to this like perfect meshes, which are like have very low poly count. So a low number of triangles, very well structured, such that the seams of the triangles align with the seams in the texture. There's all these kinds of things. There is the decomposition into materials, and 3D generative models are not outputting these kinds of assets. So I don't think that at the moment they are directly useful for the artists. And I think this is like one direction where we should work towards, is like, how can we generate assets that are closer to what artists are used to work with nowadays? Or how can we adapt the artist workflows such that they, accept and like can benefit from what we are currently generating?
Yeah, totally agree with John on this. So one thing that also is becoming more and more clear in the broader field of AI is that how well things work really highly depend on the amount of training data. Right, let it be labeled or unlabeled. Right, so the abundance of training data is also what is behind the revolution in large language modeling. Right, and indeed we have much more 2D image data available compared to 3D assets, right? So nowadays, of course, we also have all these autonomous driving platforms, right? Vehicles on which people put cameras and sensors that measure distances to closest surfaces, such as LiDAR, right? This gives you some kind of 3D data that comes in the form of a point cloud, not necessarily 3D objects, 3D models of objects, but just point clouds. But still, compared to the amount of image level data that we have, that's really almost nothing.
So now that we covered some basics, let's jump into the current state of research. And maybe I would just continue where Aljosa left off. So, I mean, you mentioned a little bit the autonomous driving. So maybe you could continue with what is the current state in autonomous driving and some challenges of autonomous driving, how difficult it is to recreate basically the human intuition, the logic, and the instincts basically to make these split-second decisions.
So right now, when it comes to autonomous driving, we do have working prototypes, and we even have robot taxis that are licensed to operate in certain areas, right? So, for example, Cruise is licensed to operate in nowadays quite a large region of San Francisco. Also, Waymo has been recently extending their operation. But what is important to note here is that aspect that they are licensed to operate in certain areas of operation. This is really crucial here, right? I don't think we have really anything close to what we could call a generalist autonomous vehicle that can just drive anywhere without any human supervision. So also just to note here, there is of course driving assistant provided by Tesla, but you actually have to supervise the driving assistance system of Tesla at all times, right? This technology is just not anywhere close to you just letting it drive and pay attention to something else. And what is crucial with this what I said, that they are allowed to operate in certain geographical areas, is that these areas are very precisely mapped, right? So these vehicles were at some level very precisely tuned to kind of roads, traffic junctions, and so forth that they can expect exactly in this region, right? And how would these vehicles behave if faced with rather unfamiliar circumstances? It remains a bit unclear, because this tail of unexpected things that can happen is extremely long. I think that in terms of research, it's not quite clear yet what else is needed to make something analogous to really generalist autonomous vehicle. And actually, one thing that I would also say about this, one thing that you ask is how difficult it is to recreate human intuition and logic and instincts to make split-second decisions. So actually, I think these are kind of two different questions. Because one is, how difficult it is to make split-second decision is, I think, a very different question from how can we recreate human logic and intuition. And here, I think that when we talk about making split-second decision, when we are doing that, I think we are relying mainly on pattern matching. Or if I use slightly different terminology, so there's this book of Daniel Kahneman that actually just recently passed. He talks in his book about system 1 and system 2 that us humans have. Of course, this is a simplification of what is going on in our brain, right? But at the high level, we have this fast system that mainly relies on pattern matching, and here we mainly just match observations and past action to the next action that would make most sense, right? This is I think how human drivers, experienced human drivers, when they drive, operate almost at all times, right? They just very, very experienced, and they don't need to think very analytically when they're driving. Of course, for beginners, this is more effort. And when it comes to recreating human logic, I think this is more of a kind of a thinking that Kahneman assigns to system 2, where you cannot rely just anymore on pattern matching, but you actually have to, involve something of a higher level human cognition. And what is also interesting here is that when you actually have to think analytically, this really takes all your thinking resources, right? You can actually get like temporarily blind to what's happening around you, right? And okay, I'm getting a bit over philosophical here, but I guess what I want to say is, I think that when it comes to really autonomous driving, I think fast thinking, pattern matching should take us, or I think it will take us all the way, right? And I think this is kind of analogous to how experienced human drivers operate. But the question of human intuition and logic, I think this is such a difficult question that I think we could probably record a series of podcasts on this. And I think that as a whole field, we don't really have too good of an idea how to recreate this. I think, as I see that this question is being discussed more and more in the community in the past year. And I think that this is partially also because people seem to think that large language models are capable of this. But I think that there is more evidence to the contrary. It's actually something that I could just keep talking about for a while longer. But yeah, I should let Žan to add his views on this.
Yeah, so I think a lot has been said. To the question of the current state of research, I feel like there is a trend of moving towards, so the autonomous driving is like, it's like kind of a whole system of things, or you need to like perceive your environment, you need to kind of detect the objects like that are influencing your actions. Then based on that, you need to kind of reason about the traffic, like what will the other assets in the scene do, and how does it affect your actions, or how do your actions affect those? And then finally, you need to output some control maneuvers. And in the past, these blocks were kind of very separate. So you had like a perception algorithm that detected the things in the scene, output like some intermediate representations, we use like bounding boxes or something like this. This was passed to a traffic model who then kind of reasoned about the scene and like maybe output some planning instructions that were then like fed into the control model that actually then put the steering. And I think recently there has been like a trend in actually kind of tackling all of this together with like one end-to-end network where we are not making discrete decisions in between. And I think that's, at least in my opinion, like a step in the right direction, because as soon as you're starting to make these discrete decisions, it's really, really hard to, on the one hand, recover from the mistakes and then cover all the cases, or there's so many edge cases. And this is what Aljosa has also touched upon. I think the tail, meaning like the cases that you very rarely see and where we humans somehow know how to operate, are so many. And just think about like how well you're driving in a city. A lot of it is like on this like communication, like nonverbal communication with the other people, or like assets that are moving in the scene. Like hand signals, like giving somebody the priority, like, okay, you cannot pass, showing this with the hand. Think about like we kind of know how to interpret these, but now we have to teach our models to interpret these, and these don't happen so often. And it's not like every person would wave their hand in the same way when you want to give priority to someone, or very uncommon assets that are coming to the scenes. Like it can happen if I see I don't know, like a family of like small ducks passing the street, I will know how to react. But this is not necessarily due to the training that I did in order to get my driving license. It was just my understanding of the world and how I should act on this. I think this is really hard to recreate, which brings me to the point that I think was not really mentioned up to now, is that I think simulation will act a really big role in getting this robotic systems to the real world. I think that we should strive to test them first in simulation before we actually put them on the road. This is like, I think for me, like one of the things that we should really strive towards doing, because of the like safety and all the other considerations, obviously. So as long as our robotics stacks or like models are improving, we should also improve the simulation to be able to be as realistic as possible and to cover all the edge cases, such that we can experience them in simulation before actually putting a system on the road or in the everyday life.
I would just like to add something to this. So I totally agree with John. I think simulation here is extremely important. So until we can convince ourselves that these systems are safe enough in simulations, we shouldn't even think about deployment. And also, one thing worth mentioning here is that simulation, from what we understand about neuroscience, is also something that us humans do very, very often. There's quite some evidence that our neurocortex implements also generative capabilities, right? When you think about some object or some person, exactly the same neurons will fire as when you see that object or this person, right? And as humans, we are also capable of online, when we are driving or doing anything else, pretty much kind of generate a certain scenario and visualize outcome of certain action taken in this scenario, right? So this, I think, is another indicator how important simulation is, right? Both in offline phase for training and as well as online.
And one final point maybe is that when we talk about autonomous driving, you often think about like the fully autonomous solution where, there is no steering wheel, no pedals. We just put our kids into the car and they like just brings them to the point B. But I think there's a lot of steps before we reach that are extremely useful already. And like both in terms of comfort in driving long distances and also in the safety scenario. So think about now, just like newer cars, often they come equipped with something like a lane assist or automatic cruise control, basically like keeping your speed and like braking in case the vehicle before you brakes. I think these probably have solved like a lot of accidents up to now, and they also increase our comfort a lot. And these are also based on some vision systems or like, just processing sensor observation. So I think that it's really exciting how this will improve in the future. There's like only the way up, I guess. And I think we're already benefiting from this without even realizing it so much because the progress is somewhat gradual.
Yeah, exactly. And actually, really just one more thing to add here, because I also feel that I didn't make this clear enough earlier, but Žan also already touched this, right? So the biggest challenge, I think, in autonomous driving is actually safety, right? As mentioned, we can build prototypes. You can even make vehicles that that most of the time will probably do just fine. But self-driving is kind of a high-stakes scenario, right? If some rare event occurs where autonomous vehicle does not know how to make the right decision, right? The consequences will be disastrous, right? And if we are not responsible at making sure that systems are super safe before we start deploying them at scale, it's not only that human lives are at stake, but also general adoption of technology that I think that has a huge potential to save human life, right? So I think that premature adaptation or deployment could be dangerous.
Absolutely. I very much agree with your last point, Aljosa. Would probably be quite detrimental for the field if there would be a premature adaptation and there are some serious damages or to human lives. And so on the topic of like ethical considerations, maybe I would to touch deepfakes, which are becoming very, very convincing, and it's really hard to differentiate between computer-generated video content and real video content, which is a huge problem with detecting misinformation, and especially in the current state of the world with all this political uncertainty. What do you think the solution would to this problem?
I really agree that this is an important topic and we shouldn't fool ourselves. All the technology that we are developing can be used for malicious intents, and this is just the way how world works. And we should be mindful of this, careful about this, but we shouldn't let it allow that we kind of like stop the progress because of this. So I think there is like a balanced view on these things. Deepfakes as one of the things that you have pointed out in terms of like just generating fake images or videos, voice of people. It's like a really big problem. So I think that there's a lot of effort in trying, like there's even startups that try to kind of develop counter systems that detect these deep fakes. I know that there's like many startups that got like funded for doing exactly this. Then there's watermarking, which means that each like assets that are generated by AI has like some specific watermark embedded into it that we can recognize and interpret, and it like tells us, okay, this was created by a generative model, and maybe even which model and what data was used to train it. I don't know what exactly is like a perfect solution to this. I don't think that it's only technical in nature. I think that we will have to educate people about the new technology and about the risks that come with it. I guess that the world where we just blindly trusted when we saw an image and we trusted that this is actually what happened are over. And I also don't think that, this is kind of the system, or it's like always, it's really hard to detect the fakes because the fakes are becoming better and better. So your model now needs to become better at detecting these. And then this is just kind of like a constant fight, and like one will constantly prevail above the other, especially because these detection methods are often tailored to specific algorithms, generative model algorithms, and specific artifacts or patterns that these models embed in the data. So I think that on the whole scope of like technology about the generative AI, we should really invest into educating people. So about like the benefits, how it can improve their lives, how it can be used to do good things, but also about what are the risks of this technology. Up to now, I've mostly seen this being used in like propaganda kind of things, like political propaganda, or things about the war. And there's of course this aspect of all the like detection and tracking and all of the things that we are developing can of course also be used by the weapon war industry. And this is just a thing that we know and like somehow need to regulate. So I think I do hope that the states or the countries, that they kind of somehow agree and find good measures to prevent these things. I don't think that this should be in the hands of like some big companies that will now control, have the total control over all these processes. But this should definitely be done by people who have the necessary education and the necessary know-how about these things. These are like highly complicated systems. And I guess even, me and Aljosa, we are not directly in the generative modeling field. And for us, it would also be hard to do these kinds of things. So I don't unfortunately have an answer on what is the solution to fight the deepfakes. I think that I would try to have like a positive message that of course there are ethical considerations. We should be mindful about them, aware about them, but there's also so much benefit that this technology can bring, and like so much good for our everyday lives. So we should it's on us now to strive on like how to extract the good and like try to like suppress the bad. And this is not the first time that this has like happened. Maybe it's the first time on this like scale, but there has been technology developments in the past that can be used for bad things, like, I don't know, from electricity and everything else that we now consider as normal. I guess that there were people at that point in time when the technology was developed that they were like scared of its like malicious use. So that's kind of my take on this. And I'll, again, like if people that are listening to this are excited about working in these directions, I know that there are some startups and companies being grounded like around this idea. Like Reality Defender is one of the ones that I know, but there are like many more. So maybe, I guess this is definitely a field that needs more manpower and know-how. So I would encourage people to also like go in this direction.
I absolutely agree with everything Žan said. I think I couldn't put it better myself. I totally share Žan's optimism about this. There is so much potential for this technology to make our lives better that we should definitely keep going fully at it. Unfortunately, yes, as with every technology, there is potential for misuse. And actually, if we just touch this aspect that was mentioned, deepfakes. So here also fully agree with Žan. I think that the right way to fight this is when it comes to education, because deepfakes are actually just kind of new manifestation of the old problem, right? Before this technology was possible, people could already kind of attempt to manipulate people via fake information, right? This was possible even before there was internet. Of course, technology brings new challenges to this, but that's the old problem that we have been facing as a humanity. I think that we should really think how to change education systems that incentivize more of critical thinking rather than learning facts by heart, right? I mean, Žan already has mentioned this, and I couldn't agree more that education is the right path to tackle these problems.
Thank you both for your input on this topic. And maybe now, before we slowly close off today's podcast, maybe let's just quickly touch on emerging trends and some open problems, and whether there is something that you're particularly excited about.
Emerging trends and open problems. So I would, so in my opinion, the next grand challenge that we actually have is really related to embodiment and robotics. I mean, we have talked quite a lot already about autonomous driving, but embodied vision and robotics really can reach far beyond that, right? I think here that the longer term vision is really to develop kind of a personal assistance that can help us with a lot of tasks, right? Not just in transporting us around and delivering our goods, but even help us to clean our house and so forth. I think that there are quite a lot of open research problems out there in how to achieve that, and I think that in this context, one of the important problems that we have to tackle is to figure out how we can learn from streams of sensor data, such as videos or LiDAR streams, and learn strong representations analogous to what people achieved in large language models from such data, right? And this is really I think difficult problem, because I think that compressing all this huge and quite redundant information stored in video is quite different to compressing text into the model, which is what essentially we are doing at the front of language modeling. And I think that another one that it's extremely important here is research calibration, and which is directly related to safety, right? I think that this is one of the grand challenges, because we should if we want to make embodied agents safe, we have really ensure that they know at some level know what they don't know, right? That they can estimate themselves when it's possibly better to just stop the autonomous operation and not try to generalize too much where it might not be safe to do so. And another thing that I would mention here, so I think that generative AI will be becoming increasingly more important, right? And we actually already have wonderful developments in this area. It's really cool that we can now generate text. We can even generate images from prompts. There are even developments on how to generate 3D assets based on prompts. But I think that generative AI is even way more important than that, right? Than being used for generating content. I think that it's also really an integral part of embodied AI and robotics, right? Because it really seems that this historic natural intelligence was developing. It really seems that this capability of generating the world, so that during online operation you can also predict outcomes of your actions, right? This was really one of the milestones development of natural intelligence, and I think that this is definitely something that kind of capability that we also will need in embodied AI.
Yeah, so I very much agree. I think that embodied AI is definitely one of the next big things that we have to tackle and solve, and it's definitely far away from being solved. Personally, I'm also very excited about training these more so-called foundation models, so more like a broad spectrum of models that are good at like many different tasks, and that can hopefully also generalize to a lot of unseen data during training. So this means training large models that can be trained mostly through unlabeled data, just through basically like sensor images, text, whatever data is available out there, and that we can then use or tune to perform different tasks. So basically learning good representation, learning so-called world models that kind of understand, have like a higher understanding of what's happening around us than like the specific task that they need to solve. I think that's personally like a very interesting thing to me. And then the second thing is also looking into more like multimodal. I mean, there is like a lot of progress, I guess, in this field already, but like multimodal data. So like, taking text and images and videos, 3D data all together and reason about being able to kind of interpret all of them together, how they affect each other. Because I feel like relying on only like single modalities, a lot is often hidden, or like it's not clear from for example, if I write you a text, there's like, or if I say a couple of words without you seeing my expression, my facial expression, or my gestures while doing this, it's often very hard to reason in what like sense this was actually meant. So I think that like doing this kind of multimodal stuff is very exciting. And then like one thing also for me that is kind of exciting is there's been a lot of talk, in the fields of virtual reality, augmented reality, and then the metaverse, and all of these things are being hyped now for several years already, and we are still not there. And I am excited about these applications, about like creating virtual experiences for people. Like, how can we create worlds where, we can experience some nice things, and, like things that we want to, and we are maybe otherwise not able to. And this brings me to like a topic that I'm not sure is like, it's very, hot, or in terms of like, it's kind of the next thing that will be tackled. But I really hope that we start using this into more kind of like ways to make people's lives easier. Like, there are a lot of peoples with like some disabilities or other things, and we should really use this technology to help them do that. I mean, there's a lot of company startups being built around this, and I think this is very exciting. Like, if we can give, for example, I don't know, blind people like a way to perceive their environment through some other neural, cognitive, whatever capabilities, like that would be really amazing in my mind. This, and then of course, all the other good things that we could do based on like climate change, all the other actual like very serious problems that I think still, even though vision is like a pretty narrow field in terms, but there's a lot of potential good that we can do in this field.
Thank you both for joining us today, and such a nice conversation. So do you have perhaps any last words, maybe recommendation of any books for listeners that are interested in the topics that we discussed today?
I think that I would really encourage people that are, I mean, if this is like students that are listening to this podcast, to like continue in the field. It's like really exciting time. Things are moving fast. There's so many opportunities, both in industry, academia. It's like really like we are moving fast, and it's exciting, and we are doing great things. And I would encourage people to kind of pursue this direction, or like other people that are interested to start learning about it. Things are moving so fast that even for us, most of the things are still new, so you're not far behind on the knowledge. Like, things are changing so drastically that we always have to learn anyways. Regarding the books, if I would have to recommend some books, I would recommend some of the classics. For example, the Multi-View Geometry and Vision by Hartley and Scissorman, I think, and then Computer Vision, Algorithms and Applications, maybe from Siliski. But these are more classical books. And then, as I've said, like the field is moving fast. And I think one of the benefits also of the universities abroad is like that they put a lot of their content online, and you can like check it out. So there's a lot of videos, a lot of lectures being available, and it's like free to use. And one can really benefit greatly from this. Like, I remember when I started, I was watching like some Stanford courses, the famous, I guess, CS, what was it, 231 or something like that, with Karpati back then. And a lot of this kind of like, knowledge is freely available, and it's on us to use it. And one final thought for me just is that in case, some of the listeners are excited about the field, have some questions, or need like some help with some things, just feel free to reach out to me. I guess you can find my contact details on online, and I'll be happy to talk about these things more. And thank you for having us, Tanja.
I also here I totally agree with John. So I remember when I was a kid, when all this PC revolution was happening in Silicon Valley, I was always thinking like, damn, I wish I was born at the time that I could be in the middle of that development, right? When things were happening. But I actually feel that nowadays that we ended up in the middle of something that seems even more exciting, right? Fast-paced progress in AI. I remember that when I started studying, especially during master courses, machine learning was seen more as something that is kind of cool but does not really work, right? Doesn't directly leads to anything. Things have changed a lot, right? Things are happening now at the fast pace, and it's really, really cool to be in the middle of that. I would also encourage the students to think about this, right? You can be part of that too. You can contribute to this as well, and we need all the resources and brain power to take this to the next level, because even though there was quite some progress recently, there are just so many open problems that need to be solved. So the things that we have been talking about today can become a reality. Now, one thing that I also really like that Žan mentioned, so Žan was really suggesting more classic books in computer vision, and I also agree that these are the right books to read, right? These are in some way, in some sense timeless, and I think that solid foundations on this topic can probably bring you in long run farther than understanding absolutely every detail of current state of the art, right? These are things that have been consolidated over generations of brilliant people working in the field. So go ahead and read that. I would actually like to mention another book that it's not computer vision book per se or graphics, but has really shaped the way I think about the field. And that's the Cognitive Robotics book by Sebastian Thrun, Dieter Fox, and Wolfram Burgat. Beautiful, beautiful book that talks about localization, filtering, and kind of puts probabilistic notes when it comes to localization, state estimation, and so forth. So I think, at least for me, philosophically, was very important. I also would really encourage people to, one thing I think it's in general important technology, is to have a firm understanding of how not just people in the past, but also what kind of solutions nature found for difficult problems, right? And there are many examples out there, right? Nature or evolution has already found a way to create intelligent autonomous systems, right? We are examples of such systems, and there are many beautiful books around there that talk about how intelligence emerged over the course of history, right? And I think that sometimes even understanding how human brain works is not the right thing to think about. It's possibly more important or more tangible to try to understand how the earliest intelligent animal over time acquired new functionalities and repurposed old, learn to survive and thrive. And one particular book that I would recommend in this context is The Deep History of Ourselves by Joseph Ledoux. And besides that, I would also really like to thank Tanja for inviting me to this wonderful podcast. It was really fun to participate, to have discussion with Žan, and I would also say the same. Anyone that would like to reach out, has any questions regarding studying abroad, or just anything else, feel free to reach out. You'll also find my email, contact details on the web. And thank you both.
Thank you again.